let's talk more about data modeling. In particular, if you saw the last video, we mostly focused on your standard concepts in data modeling, normalization, denormalization, and a few other just key concepts. But it really ranged from traditional, relational databases to data warehousing. So it wasn't very pointed at the kind of data modeling we do as data engineers, which is important to point out that obviously data modeling, again, goes both for the operational, otherwise known as transactional side, as well as the analytical side of your data. So today, let's talk about the analytical side. In particular, we're going to focus on a few key things. First, a review, if you have by chance not had a chance to, of the key tables that you will likely see. We'll just cover a few of them. There's honestly plenty more, but we're just going to cover the key ones for today. We'll go over a few of the scenarios you'll likely end up in terms of decisions you have to make, and then we'll go through an example that is put out by Kimball in his data warehousing toolkit, which honestly, a lot of people ask for examples. There's like a dozen in his both books and some of his online content. You can find a few good examples of how you can develop your own data model. So let's just jump into it and talk about some of the key tables in data warehousing, and more specifically in dimensional modeling, since that's where we're really going to focus on. So obviously there's plenty of tables here. We're really just going to talk about facts, dimensions, bridge tables, and snapshots. And then again, this will be a good refresher for some of you. And if not, if this is new, it's really good information to know. So if you look at your traditional data warehouse, you'll generally see a few facts and a lot of dimension tables. This is because the fact tables, if you look at what they represent, generally are the, at least pulling from the data warehouse toolkit, primary table, essentially in the dimensional model, where the numerical performance measurements of a business are stored. Basically, these tables contain often the quantitative data that represent the transactions, events that occur in a business or organization. And I say organization because this isn't just your sales fact table or your fact sales table. There's also the opportunity or option that you might have a grade table or an assignment table. If you're some sort of education system, you might actually include a different type of fact table that has nothing to do with the business transactions, but more to do with organization. You can call it a business, but I'm sure some people would like to delineate the two. The point is, these tables generally are the tables that have the events that you're going to be aggregating and summing on, doing division. Again, there are some other types of fact tables that we're not going to talk about today that you're going to run into issues if you do that. But in this case, the plain vanilla old fact table is the table you're going to likely answer all of your questions from, right? Like it's all the numbers, everything there is going to be able to be aggregated, sliced, diced, etc. You're going to be able to basically find data, things like how much you sold for product for, again, maybe what grade someone got for an assignment, how much inventory is left essentially in your warehouse, or how much inventory was essentially moved outside of your warehouse at a certain point. Or maybe if you've got like an invoice fact table, which we'll talk a little bit about here in a second, the line items and how much people pay per thing and the quantity per thing that you're actually paying for. And so again, it's all of these like numeric things. And so this is kind of a good example here of a fact table. You'll see a lot of keys that will point out to the dimension tables, and then a few specific quantitative values. And then that brings up obviously the dimension table. And if you're an analyst, the easiest way to think about them is that these tend to be the tables that have the information that you often slice and dice by. And when I say that, I mean like when your leadership asks you a question, they often ask you, how are sales going for this quarter? And we'd love to see a report quarter over quarter, broken down by region, and maybe sales representative. So in this, you have the fact, which is sales, so how much money was actually sold per region and the quarter, etc. And the dimensions, which were all of those other things that I referenced. The quarter, which is date and time. You have things like region, which is a very common dimension to work off of some sort of location. And then finally, sales representative. So a person or something similar might break that down. You might also have things like departments, accounts. There's a ton of different things that could be here where someone generally wants to slice and dice this data by. They are the dimensions. In, again, Kimball's book, he calls dimensions attributes that essentially serve as the primary source of query constraints, groupings, and report labels. In a query or report request, attributes are identified as by words. Attributes are identified as the bywords. For example, when a user states that he or she wants to see dollar sales by week, by brand, week, and in turn, brand must be available, essentially as an attribute. So again, there are these other pieces of information that don't always change. There are slowly changing dimensions, but that's not something we're going to cover today. But they don't often change. And so it's what you're going to report off of. Now, these are likely the most common tables, at least the ones I've seen. Some data warehouses get more complex than this, but those are likely the most common tables you'll see. Along with that, you'll likely also see a few other things. We're going to cover snapshot tables and bridge tables here next really quickly. Snapshot tables, kind of as it suggests, is a snapshot often of a fact table. So for example, one that I used to see a lot is often like monthly sales. That'd be taken a snapshot essentially of. That way it was just pre-aggregated, so you'd save compute and sometimes save space if you like, for example, deleted or maybe partitioned data after certain points in history. So you could just have the snapshot in time, which again saves compute, but also can save essentially space if that's also required. There's other reasons you might also see it. Sometimes I've seen snapshot tables because people don't want things to change. So if you have a report, and yes, things might change in the past, and for some reason, management doesn't want to have to deal with those changes. They just want to report whatever the actual data was then, even if there were some slight changes. Sometimes people will do snapshot tables. And then finally, bridge tables, which we'll talk about these more here in a second. But bridge tables are another table that most places will often tell you to try to avoid, because what they tend to be are tables that represent many-to-many relationships in between two dimensions. So what this generally means is, let's say in the example they always give, patients, for example, if you go to healthcare. And this was something that was always weird, I think, when I worked with healthcare data. You might get multiple diagnoses when you come in, right? Like you don't just come in to the doctor sometimes and just have a headache. Maybe that's all you do, but maybe you've got a headache, maybe you've got a broken arm, maybe you've got, 7 different things. And so they're going to, reference all of those things. And honestly, same thing with treatment. Like treatment might have multiple instances on one of these cases. So what ends up needing to happen sometimes here is that they will need to put some sort of center table or bridge table that tries to deal with this many-to-many relationship. In the example that they give on Kimball, or at least Kimball's website, I like this because they've got a weighting factor in it. They do account dimension and customer, and essentially, one account could have many customers on it. And I think they put the weighting factor in there, and they ended up having to put this weighting factor in there just because of the fact that one of the problems you're going to run into here is that if you do this, it's very easy for you to accidentally overcount something, because this join is now going to create possibly 3 or 4 rows for something that maybe in that fact table meant to have 1 row. And so now you've got to add a weighting factor and it gets real weird. Another thing that this kind of causes a weird issue with is, like, if there's only one line, it still only is one line, even though you've created this grouping table. Again, this middle table is like a grouping table that groups all of this other thing, or groups all of your many relationship to something else. And so it makes it really weird. And so it's generally discouraged to use it, and they've given you a few good reasons and how you can switch it around with this. And they give you a few examples of how you can get around this in this article. All right, so now that we've gone over the basic tables, let's talk about some of the key issues or key decision points you'll end up having as you're building out your data warehouse. And one of those is the classic header and line item modeling, maybe not conundrum, but design decision. So what I mean here is, let's talk something like invoices, orders, or anything where there's an initial parent and essentially child relationship. Invoices is an easy example of this because here you could have the header, right? And the header generally has things like who purchased something, when they purchased it, when was the agreement signed, a PO number, and it's all very high level. But underneath that is individual line items that say, hey, this is what is being delivered in this invoice. If it's in construction, it might be lumber, there might be some time and materials, there might be windows, there's tons of things. They have different prices, different quantities. They might be delivered on different dates. They might be signed off for on different times, right? Like completed and actually implemented in different times. And all that generally gets collected. But as you can see, you can't just have this all in one line because, again, there's multiple line items. And so they actually do have a good article or a good point about this here. Again, on Kimball's website. All this content exists already. There are much smarter people than me that have thought through how you should be designing a lot of things. So they've already covered some of this here. And the way I've seen it, honestly, done okay, is often you will have a header fact table and a header or a line item fact table. So you have to join these two, which is generally avoided for multiple reasons because it takes a long time, oftentimes. And that's probably the biggest thing is you're joining 2 big tables, which will be compute expensive, which will be expensive on the compute side, and it can just get weird. And that's probably why, if you look at Kimball's example, he actually goes through it and kind of tells you probably shouldn't do this and recommends you try to do a single table that acts as your single table. And he recommends you do a single table for your fact table, where it's your header and line item data, where it's your header and line item data all in one. And again, the reason this can be somewhat helpful is you're avoiding having to join two big fact tables, and that can, again, be very expensive, might take a long time, so it's not necessarily a bad idea. I think the one thing, and this is even if you have it in two separate tables that you run into, is people need to know that, for example, invoice number represents something that isn't unique. And this is one of those things that you'll often talk about as you're modeling your tables, is granularity, which if you do not know the granularity of a table, or if you haven't defined it and you're just building a table, is asking for problems. So in this example, your granularity is not invoice number, although some people might think that, and that's where you need to be very careful. Your granularity is invoice line item, essentially, or maybe you can do invoice number plus, invoice line item, or invoice line item number, could be line number. That way people know that those are unique. And if they want to count unique invoices, they have to count via distinct, right? Like they're going to have to count transaction number via distinct. And that's a very, some people might not like that, but in this data model, that's what you're likely going to have to do to get distinct counts of transaction numbers. Again, in this case, you're removing the need to join two fact tables. You do take on some possible, risk. You've denormalized the data a little bit here. So you take on a little bit of risk of having to update that data and having to update the header data in multiple places. But overall, I can see why Kimball recommended this setup. I've seen both work. I'm really trying to remember if the line item and header fact that I've seen took a really long time, or or how long it took to run. Because I want to say that actually did cause some problems at the company that I worked at. Someone else had modeled it and I was working on it. This was one of the first jobs I had. And I do feel like I recall it being very, very slow when I tried joining those two tables, and occasionally just dying. So I do kind of get why they're recommending you have one table. Because again, otherwise it's going to be very, very expensive. And in some cases, just if you've got a local on-prem system, it might not make it if you run a query on that. Again, another design decision that you're often trying to make and trying to avoid is the bridge table design choice. In fact, there's a few different articles that you will find, and it could just be that they're all stemming from Kimball, but they all kind of recommend you try to avoid this bridge table. It makes sense, but it can also cause a lot of issues. Again, if you're trying to join all this data, you can easily end up double counting data, because again, if you have multiple dimensions that go to one single line item in the fact table, you're now going to blow it up into 4 or 5 lines, and you're counting the wrong thing. Kimball's example, I think he used the weighting factor. And actually, Kimball, again, covers a few ways you can try to work around using a bridge table. I've seen a few of these. For example, he references possibly putting multiple columns. So you can have in the example, patient diagnosis. I've seen this where it's diagnosis code 1, diagnosis code 2 to 5. And again, it's called out in his own article that this is not a scalable option. This is an option. And if you know you're only going to have 2 or 3, it can work, but it also is very weird. It makes it very hard to join, obviously. These days also you can do some sort of nesting or an array or something. It's possible. Again, these are design decisions that you're going to make. There's always trade-offs. You can do a bridge table. The trade-off here is there's some risk that maybe someone joins it and doesn't realize that they've just exploded how many rows they had. On the flip side, if you put it into an array, or if you have multiple columns, now someone has to either figure out how to unnest that array, or they have to figure out which columns are null and which columns are not null in your essentially column, diagnosis code 1, diagnosis code 2, etc. And it's not, again, scalable. And these are just a couple solutions. I'll put up a few of the other ones he recommended. Again, everything is a design decision. If you have done something in this situation where you need to do a bridge table, or you had to figure out an alternative and you found it successful, please comment below. Again, these are things that I think are valuable to share to everyone. I hate it when people just say maybe I see something that's incorrect. That's fine. You can correct me, but share a good example of what a better option is, right? If you have a good example of what you do instead, please share it below. Everyone will benefit, and then I'll hopefully include it one time in the future, because I love learning. Feel free to add comments below of how you think these problems should be solved. Again, these were just a few examples, but I'm sure there are more. Now let's get into a quick example, which again, I'll put these examples exist in Kimball's book. So I'm going to go through it, and I'm going to kind of put it up here. But honestly, you can do it yourself. He's got more than what I'm just putting out, and this is just one person's perspective. I'll put up a few books here about other data modeling concepts you can look into besides just dimensional data modeling, or at least Kimball's book on it. So retail sales is the one we always look at. We talk about invoices here. retail sales tends to be the easiest to explain. You have your core fact table, and again, here it is, which is just this transaction fact table, your sales fact table. You have the date, which could actually have multiple places that it could fit in, right? The day it was purchased, the day it was delivered, etc. You have the store that often it was located in, or if it was sold off of Amazon and not a retail store or in-person store, right? It might have like categories, which will be likely in product. This product will likely have some sort of hierarchy connected to it, which will either be in the product table or maybe you've got a hierarchy type of table system going on. And then promotions. Promotions are often included as well. And I love that they're included because when I interviewed at Facebook, which at this point, man, we're getting close to 4 years. It was a long time, or past 4 years, at least when I interviewed. I remember that table existing as well when we did our interview. So promotions is a valid table, and I think it's good that it's here. What I really enjoyed about, if you go through this book and if we go through kind of step-by-step for this data model is they actually kind of talk you through the process of creating this data model. Step one that he calls out here in this chapter, which is essentially the retail case study, is to first start out with the business process. Like he's kind of called it out. So okay, let's start with the business process. After that, once you kind of understand what the requirements are, what the business process is, you can declare essentially the grain. So once the business process has been identified, the data warehouse team faces a serious decision about granularity. What level of data of detail should be made available in a dimensional model? Generally speaking, most people want it as low as possible, but how low is too low? I brought up like courses earlier. Do you want it at the course grade level? Right? Like, okay, you got an A or 98, or do you want it to an assignment level, right? Like, do you want to know exactly how well someone did on an assignment, which just depends on what questions the business wants to answer. Again, it starts with the business. That's where data modeling starts. We talked about that, conceptual modeling. It starts with the business, understanding the process that they're doing. Once you understand that, then you can start putting around the actual dimensions there, because you're going to know, hey, what questions are we trying to answer? Okay, we're trying to answer questions on the category of this product. We're trying to answer questions around date or around promotion. Okay, we know we need a promotion table because some of these tables might not be right where you need them, right? Like some of them will be in your application, some of them will be in Facebook or your Facebook marketplace, right? Like that's going to be where the advertisement was, or Bitly, because you have Bitly links that tell you where the advertisement is or what advertisement or promotions was connected to. So you need to know what you're actually going to need to collect. Honestly, generally finding the fact tends to be the easy part. All dimensions, in my experience, is going to be the hard part because you don't know where that lives. Some of those dimensions are not connected to that fact directly. If you're lucky, they are, but not always. And then finally, you identify the fact. And in this book, he says, again, the grain declaration helps anchor our thinking. Simply put, the fact must be true to the grain. The individual line items on POS transaction, in this case, when considering potential facts, you again may discover that adjustments need to be made either our earlier grain assumptions or on choices of dimensions. And what I enjoyed there is that he's being honest to the fact that, hey, this is a process, right? You're going to go through different layers of this whole process, understanding what the business wants, understanding what granularity that could be at, understanding what dimensions will be required, understanding what facts you can collect or what facts you have. And from there, iterating, because things will be wrong. Things will be wrong. You're going to make some assumptions that were wrong, and you need to iterate and fix them. This process is generally how most systems operate. Now, what I also really enjoyed, again, about this book is then he takes you through dimension by dimension, helping you define what should be involved, right? He has your date dimension here, and he has your product dimension. Again, I reference things like, you might have things like category or department in there in terms of like description, because these are often the ways people want to report out on data, as well as things like brand description. And there's going to be a lot of stuff that he points out that is very important and why it's important. And from there, he goes through store and promotion dimensions, and all of that can be seen. And it's not just a quick overlay of how these dimensions exist. It's also decisions you need to make as you're building out these dimensions. And honestly, from there, he continues to build on this same data model and covers things like extending it. So if you want to add more things to it, like maybe shoppers, and he calls them frequent shoppers, but it can be shoppers, it can be clerks or employees. He really tries to cover, okay, here's how you can continue to expand it. And also, here's some pitfalls you might run into as you're building this and trying to do more and more with your overall system, like overly dimensionalizing things, like adding way too fine of dimensions, essentially. For example, he covers the whole concept of snowflaking, or adding more and more dimensions, or not adding more, but normalizing essentially dimension more and more, which can make sense, but again, he covers some of the reasons and pitfalls that I'll put up here that you will have as you're going through this process. And I really, really enjoyed that fact. And I think, again, I can cover everything here, but I think you're going to get more from actually reading the content. Again, with that ends this video on data modeling. I'm going to keep going on this. I really do enjoy the subject, so we'll probably go over a few more examples, maybe a little more in depth, since we've covered now facts and dimensions and a few gotchas. We can go a little more in depth in another chapter. If you have any chapters that you've kind of read or want me to read through specifically, comment below, and I'd love to kind of read through them. I'll link the Kimball book so you can actually pick a chapter. Also, I still need to cover one big table versus essentially dimensional modeling, so we'll do that as well. And with that, guys, thanks so much for watching this video, and I'll see you in the next one. Thanks all.